Hello everyone and welcome back to another episode of Extractions&Ire. There hasn't been one in a while. Just thought I'd start in the lab here and point out my lab wall because it's got a new symbol on it. So thanks to Aussie Chemist for that one. And I think I did a pretty good job with the artwork. Yeah, look at that chalk skills. So this video is on the Great Iodine Mystery, which is a bit of a strange title, but it's not currently in the lab. So we are going to go find it. That's the microwave. This is the CD corridor. Oh, I thought I'd give you some life updates on the way because I haven't done a video in a while. Really just pushing these Extraction&Ire, fucking explosion and fire videos. So the amine peroxide one took me a lot of time, so I haven't had a real chance to do the benzene synthesis like I really want to. I really need a full day for that. I've been really busy at uni doing things, but I will get to it at some point. This is a greenhouse that my dad is building for my mum, just in case, you know, we weren't seedy enough. We now have a lab and a greenhouse. Still no drugs. The biggest update is possibly that I have a new phone now, which is what I'm filming on, which is a Google Pixel. I'll be paying it off for the next couple of years, but I hope you appreciate the improvement in quality. Anyway, here we are in this little... This used to be stables, as you can probably tell. Now we just use it for shit storage. But this is where our mystery is hiding. Yeah, this container here, lying in wait. Alright, let's get this back to the lab. Ugh. Oh god, it's heavy. Ugh. So, my grandma used to run a vet practice quite a few years ago now, and then she finally moved out probably about 2 years ago now, and you know, it took her probably about a year to sort of started packing things up, and in one of the sheds we found this container here. Now, all of us assumed it was hydrochloric acid because a lot of the other containers were around there were empty hydrochloric acid containers from the pool and such. When we finally opened the container, we found that it was not hydrochloric acid in there, and nor was it empty like most of the containers were. It's full of a dark brown purple liquid. Straight away I thought, I have hit the jackpot. This is 20 or 30 litres of providine iodine solution. This is a lifetime supply of iodine. I thought, there's nothing better. Well, there's a lot of things better than this, but I straight away claimed it and took it home, and it was mine. But then the problems started happening. Let's get some out. And as we can see, it's this dark brown. It's not really purple, it's really nearly a browny red liquid. So when I first got it home, I started doing some experiments with it, and at that stage, it was quite a few years ago, so I was really just copying exactly other YouTubers' videos at the time for extracting iodine from providine iodine. That really involved, I can't remember exactly, this is why you take notes. But you add like sodium hydroxide to a base to it, and then you boil it down, you get sodium iodide out, and then you can acidify it with hydrochloric acid and hydrogen peroxide, and you can get your free iodine out and you can filter that off. Seemed relatively simple. However, whenever I tried it with this solution, it didn't work. And for the life of me, I couldn't work out what was happening. And I would just get this kind of mildly brown liquid that no iodine would separate off from it. Okay, so I have some distilled water here, so we're going to dilute some. This stuff is quite annoying to work with because it is intensely staining. That's pretty good. And we see on dilution, we have our first observation that everything in that solution is miscible with water. So there's no harsh organic solvents in there. It's obviously either in water or a similar thing to water. What I'm going to do, so both me and you can keep track of things, I'm going to keep writing these the stuff we know up on the board as our evidence of what we think it is. So hopefully we can all draw a conclusion after we've done all these tests. Now the first difference we have for this solution than normal iodine solutions is that we find it's actually acidic. Now, I found this out first when I accidentally spilled some on the concrete, and it started reacting with the concrete. It's very hard to see in the non-diluted form because the intense staining of the iodine will stain the pH paper, but we can see it is considerably acidic here. So this explains why the normal extraction of iodine from provident iodine doesn't work, because there's an acid in there, it's reacting with the base, it's then putting out crystals as well, which then, as I gather them and then make up the solution, acidify it, and then, you know, that's this, whatever acid is in there is reacting and screwing everything over. Does that make any sense? But yeah, so normal provident iodine is not acidic, so you don't have to worry about that. But here, something is reacting with the base and giving a salt, which is screwing with the normal iodine extraction process. We could also demonstrate its acidity by putting in a tiny amount of sodium carbonate, and we can see it bubbling away quite nicely there. However, it does not react with aluminium. So this implies that perhaps we have an organic acid in here, because if it's a mineral acid like hydrochloric, sulfuric, they'll react with the aluminium. Of course, nitric won't, so there is still a chance we have nitric acid in here, but I think that's, you know, very much doubt that there's nitric acid in this solution. I could be wrong. Alright, to see if there's some sort of organic solvents in here, what we're going to do next is distillation. So we'll see what's in here by measuring the boiling points of the solution. Okay, here we are, it's heating, it's just in a simple oil bath. The temperature reading is coming from in there. We've got an excessively long condenser getting its first run. You can see the joint size is wrong, so it's from that glassware box that I didn't really buy. Alright, our liquid has just started boiling in the last 30 seconds, and something has just happened here in the adapter here, if we could actually focus. We can see that it has a slight purple coloration to it, and more so if we go in really close and actually try and focus. You can see that the adapter here is covered in, this kind of looks like black kind of dirt on the side here. That's actually iodine crystals. So in essence, what we're really kind of doing here, it's weird, but we're kind of steam distilling off iodine. It's a bit weird, but the iodine doesn't come out like this until the solution starts to boil. And then we start getting iodine crystals subliming off. Well, it's coming out of solution and it's all condensing here as a solid. That lets you know that there is kind of free iodine in solution in a way, because when we boil it, iodine comes off. Alright, we just had our first drop reach here. There's our drop. What temperature are we at? We're at 92. Really, I think everything here is water. You know, because I think this thermometer is just a little slow at catching up. And, you know, I think every thermometer is a little bit slow at catching up with a setup like this. But, you know, the fact we'll add to the board is we'll say something like, so there's nothing in here with a boiling point under 90 to be easy, but I'm fairly sure water is the most volatile solvent or substance in this solution. Here's our first few drops of a murky brown material, because I'm fairly sure iodine has at least a reasonable solubility in water, which is what is tinging that that liquid, assuming it's water, which I'm fairly certain it is. And what will be interesting to see is if this first drop is acidic or not. Because that will tell us if our acid we're dealing with is volatile, like HCl or nitric acid, or non-volatile, like anything else. We already know it's probably not hydrochloric, because we don't see a reaction with aluminium, but this will rule out nitric acid if it's just neutral coming over. Oh man, there is so much iodine in that sample. You see it floating on there. Yeah. Alright, so that's coming over at a temperature of 97 degrees. So it's probably water, but there could be something in there that's slightly reducing its boiling point, like an acid or something. So let's check the pH of that liquid there.
Alright, that does not look acidic.
So there's quite a lot of iodine. You can see it packing up in there, up in the top here, floating in the water here. But I think this isn't a very efficient way of getting the iodine out. Like, apart from the fact it's very difficult, like, for me to recover this iodine, I need to then do this distillation and then kind of like assume a lot of it will come through in the water and float out and then kind of filter it. But that's not, I don't think it's getting a lot of the iodine out, because the iodine in the solution isn't just native iodine. It's probably, you know, like complexed in there, like it forms a triiodide ion. So for every like bit of elemental iodine, I think there's a sodium iodide that I'm not going to get out from this method. So that's what I think anyway. I could be completely wrong. Like, for example, if there's an acid and there's like a mild oxidizer in that solution, when I heat it, maybe it's forming the elemental iodine, you know, just that sort of thing. So I don't know, like, so maybe I don't need to solve what's in the solution. I still need to, because what if there's something cool, and maybe I could design a setup to just get the iodine out via heating. I'll have to think about that. Just one thing I have noticed happens is if we take this, it's just starting to cool now, and this is pretty wet with stuff that's just kind of distilled out of there, and then we put it on the pH paper. We see that it is marginally acidic. It actually does register as a little bit acidic, not as acidic as the actual bulk solution, because even when we diluted it, it gave it really red. But it is there. Perhaps the acid is slightly volatile, but it's not really coming over, because if we look at the pH of this water that's coming off, no, it could perhaps be from the iodine. No, it is definitely looking red. You're right, so maybe it is coming over. But it definitely didn't come over originally, so it's not coming over with the water like hydrochloric acid does, so it's either possibly got a boiling point slightly higher than water, or it's got an azeotrope that is sort of starting to come over, because it started off not acidic and is getting gradually more acidic. So after distilling all the water off, we're left with this sludgy kind of mass. It's actually not too sludgy, but we didn't really get all the water off it, I don't think. Let's check if it's still all miscible in water. So I've just got a little vial of distilled water here. And that looks pretty much all perfectly mixed in there. That's all dissolved, so we haven't formed anything that forms a new layer in there. Alright, when we crank the temperature even further, and I'm sorry I've been a bit slow in filming this coming over, but all of a sudden this horrible smell starts to emerge, and we distill over this organic brown liquid, brown black kind of thing, which settles on the bottom here. You can see in the droplets. Really, it's coming over kind of at the same time as a clear liquid, and it's hard to tell if it's kind of, they're both kind of just coincidentally coming over at the same time, or if it's kind of an immiscible azeotrope coming over, which would be really interesting if it was. The temperature's quite high. It's not reading it very well on my probe, just because I don't think there's not enough coming over, so the temperature's been falling. But this only happens after all the water's come off. We can measure the acidity of this as well, coming over now. I have a feeling it's going to be very acidic. Let's have a look at the boiling flask. What does it look like? Yeah, horrific. Well, I think it's like foaming up, is it? Ooh. Oh yeah, shit. It's foaming up all the way up to there. Shit. That's horrible. I'm going to turn the heat off. The smell is horrendous. It's sharp. It smells like I'm getting cancer. It just, it really like, it's not like putrid, like some, like hydrogen sulfide, which makes you kind of gag. It's really just like kind of really cuts through you, and it does kind of make me want to throw up a little bit, but just because it like cuts through you really a lot, But I don't really want to be around it a lot, because I don't actually know what it is, so it could be very, very unhealthy. Like, we could be making some sort of tar here, and this could be a crollium for all I know. I'm not sure if that's miscible water or whatever, but there's all those kind of things with that level of toxicity which we don't know if we're forming or not. Yeah, there's something in there that's coming out now. Whether it's, I think I might scrub that. Nothing but boiling point under 90 degrees. I might scrub this because this may have a boiling point under 90 degrees. I have a feeling it's not, but it may be that only when the temperature gets, you know, to 120, then we start forming this organic liquid that could have a boiling point of, you know, 70 for all I know. But definitely water comes over first, gets slightly more acidic, and then I might get rid of that, not volatile acid. It's slightly volatile because it seems like it's starting off not very acidic, getting more acidic, and then all of a sudden this this shit starts to come over. Horrible stuff. I've really gone above the smoke point of my oil as well. That's why it's all smoking everywhere. But maybe this is useful. Maybe it's some cool solvent or something, but it doesn't smell very good. So, but yeah, we should learn what it is somehow. Alright, so the stuff coming over now is wildly acidic. A lot more acidic than what was coming over earlier. So that kind of leads support. You can see the red kind of coming through the. I'm getting a bit of light, kind of coming through the purple there. Kind of. Well, I can anyway. You just have to believe me there. So that kind of lends argument to the fact that it's starting off less acidic and getting more acidic. Alright, so we're going to try the same experiment now. I've got a bit of fresh solution in a 50ml flask. Except this time we're going to add some sodium metabisulfite to it. And this is going to reduce the iodine without really impacting the acid. Well, I don't. When I originally designed this experiment, I did this experiment probably about 3 years ago. I got really sick of the iodine coming over, and I thought I couldn't add sodium hydroxide because that would get rid of the organic acid, which I think is in there, or the mineral acid, or whatever. We're at about 72 degrees, and we can see the reaction flask has gone all milky. I don't know why that is, but it happens. It probably happened at about 50 degrees or so. It sat overnight and didn't go milky, but on heating it did, so something is happening. We'll get it up to temperature where it starts boiling. So I've collected two fractions. They're identical looking, just they're in two separate fractions just so we can perform tests on them later. But now interesting things start to happen. We can see that the distillation flask is starting to go brown. So we're reforming some iodine or something. So the stuff coming over now is quite milky. This may be a thing from the sulfite or something, you know, maybe forming some sulfur or something like that. That's kind of what it looks like a kind of sulfur kind of suspension. It definitely looks like we're forming some iodine in the flask there. You can see the purple in the headroom of the flask there. So I've been trying to heat and boil this stuff over for quite a while now, and it looks like it's kind of charring the brown stuff. There's that smell there, which is the thing I wanted to distill over. So these are our four fractions. We start off getting two clear fractions over. They're basically exactly the same fraction as far as I can tell. Then all of a sudden we start getting some sulfur over in the distillate, which is a bit strange. And then the distillation flask goes purple, and we start getting over the two layers, this organic layer and this clear liquid. And I believe it's the organic layer that smells very, very bad. What's also notable is that the appearance of the sulfur has a marked change in the pH. It gets a lot more acidic. It's all acidic all the way here, but this may be just because of the sulfite producing some sulfur dioxide or something like that. So this so it seems like it drops in acidity between these two fractions, but then it really gets quite acidic here. Right, finally we have all this evidence, but I thought run an NMR. So I kind of have access to an NMR, but I haven't really got permission to run, you know, samples outside of what I'm meant to be studying. So, and that's a hard question to ask. Like, oh, can I just run NMRs for other things? Like, you know, what do you want an NMR? So, rather than have that conversation, so I ran one NMR, just the neat, well not neat, but just the iodine solution is some DMSO. to pick up any organic stuff. So have here, this huge stretch here is the water, so just forget about that one. This here is a DMSO, I'm fairly certain. So we've got peaks here, here, and here on the proton. So this is the DMSO. We've got quite a few peaks here in the carbon NMR. So these are all in the description and the zoomed in section, that sort of thing. A lot of you won't be familiar with how to read NMR, and I'm not great at it, because maybe you'll be able to look at this and tell me what's in here just by the NMR. But just to point out a few things here, is we don't see any large carboxylic acids kind of broad stretches. There's a possibility that we're just not seeing them, because sometimes you just don't see them, but this is what I fully expected to see. I've cut this off at 8, but I ran it all the way up to 16 ppm, and we don't see any broad stretches from the carboxylic acids, which is interesting. I was expecting there to be carboxylic acid stretches in there. Also, we have these two signals here, which are down in the kind of the aromatic region, and same with, I'm fairly sure off the top of my head, these singles here, which look like a doublet or doublets. So we have two signals down in the aromatic region, which is very surprising. So it's likely that we have something aromatic. It could not be aromatic, but that's kind of where you expect aromatic signals to turn up. And then we got kind of some signals in here, like a 60 and a 41. 31. So this video has probably been very confusing, but we got some evidence here. Let me know, you guys are very good at solving problems in the comment section. Let me know if there's any other tests you want me to do, because I would really like to know what to find out. And when we're thinking about this, we got to think back to its original, where I found it in my grandma's shed. So we got to think, why would these chemicals be together, and what is their purpose? So I assume it's either for disinfecting or cleaning, or both. And so really, the chemicals have to kind of have a purpose. Like the iodine is obviously probably in there to disinfect, like, you know, tincture of iodine kind of solutions are. But the acids and any of this organic stuff that's showing up, why is that there, and what is it doing? So maybe you just know that there's some sort of industrial cleaning thing from 30 years ago, and I can find an MSDS and it tells me what's in there, and then I can check on the NMR to see it all checks out. But if not, so I'll just run through the thing. So it's all miscible in water. When we first have it, it's quite acidic, but we don't see any reaction with aluminium. Whether I'm just not pacing that enough is unlikely, because I've left the aluminium in there for a long time. So it's unlikely to be sulfuric acid, even though it seems to behave like sulfuric acid, in the fact that the distillate gets more acidic with time, so that we start boiling over basically just water that's slightly acidic. And then when we get to near the end, when it starts to char up, the stuff we're distilling over is really heavily acidic. The reaction with sulfite reduces all the iodine, so we don't pump off any free iodine, but at some point the mixture goes purple again, which implies that maybe the purple isn't just from the iodine. And we also get some sulfur in the saline flask. I don't think that test shows us much, but something to think about as well. And then the final test, above 100 degrees, after we've boiled off all the water really, we start to have a reaction that produces a new immiscible layer, which smells really terrible. I have a feeling it produces it rather than it just being in there, because otherwise I would smell it in there. But the smell isn't in there without the heating. So whether the acid has catalyzed something, or there's a polymer in there that's breaking down, or some iodine is reacting with something, I don't know, but that's what's happening. So yeah, give me some suggestions or tests to try out in future, and together we can see if we can find out what it is. Alright, I hope you enjoyed it. This is going to be a real mess of a video to edit, but good luck to myself. Yep, and I've also destroyed the benches for this video, so the benches were getting pretty bad, but you can see in patches. Yeah, stained it. That's just me being careless though. Anyway, alright, I'll better go. Alright, thanks for watching. See you next time.